All right, stat students. So this week I've been putting up like videos very sporadically. I apologize about that. So not only I have to make this one separate because this is going to be one topic in this video, and it's going to be over standard normal curves. So it's going to be very short. But then there will also be another video. I've got to separate AP and dual credit for this one. So I've got to work a little double time here for getting these videos out. Okay. So I'm not gonna speak anymore. We're just gonna go ahead and get right into it. Let's talk about a standard normal curve. We've been looking at normal curves right here. We have the 68, 95, 99, 7 rule. We can use that to help us do our homework. There will be another homework assignment that's gonna have to come out next week before we take our test. And it's going to be over other calculations with a normal distribution. But let's go ahead and talk about a standard normal curve. A standard normal curve is a, so we're going to say definition here. It is a normal curve with a mean of blank and standard deviation of blank. Okay, so we standardized our data in our transformations lesson. Okay, so we took our heights and we said, okay, we're going to add 10 inches to all of them. Then we took our heights and we said, okay, let's convert them to centimeters. And then the last thing we did, which I'm pretty sure I did, it's been so long now, I've made so many videos, I know I did it in class, so hopefully I'm not wrong on this, is we standardized the data. So what happened when I standardized the data? That meant I'm going to change them all to z-scores. So x minus x bar over s of x. That gets me my standardized data. Well, what happened? Well, that made the mean 0 and the standard deviation 1. Okay? So a standard normal curve is a normal curve with a mean of 0 and a standard deviation of 1. So this is let's put another talking point here. This is a distribution of z-scores. That's what standardized data is. It's just z-scores. And so we can ask questions about this. This is sort of the notation for n is 0, 1. We talked about that notation, I believe, in the last video. And we have an example that we want to look at. So in our notes here, we want to build this density curve. That's a standard density curve here. And so please go ahead and draw this on your notes, okay? Draw this in your notes. And we're going to draw the 3 lines. I need to use black and no pointer. So remember that first deviation is where the inflection point is on either side, and it's symmetric. Right there, that's as good as it's gonna get from me. There's another here. And by the way, these don't have to be precise. If you're working a question, you can make the easiest simple sketch that you want when you're building any of these sketches. You don't have to overcomplicate this. I'm gonna switch to my mouse. I think it's just better. Okay, so every time you build a density curve, a normal one, you want 3 deviations both ways. So if I am building this standard, so this is a standard normal curve, we get this right here. In the mean, this is the mu here, and this is the sigma. We introduced those yesterday. So what is the mean? Well, it's 0, okay? And then the deviation is 1. So I go up 1 deviation, up another deviation, and up another. Then I go down 1 deviation, down another, and down another. Okay? So now I can answer these questions, and we're going to ask what percent of the data, so question 1, what percent of the data is above -2? Well, we have our percents that we used, And remember how we did that in the last lesson? We're just going to add all these up. So it's 13.5 plus 34 plus 34 plus 13.5 plus these. And we know that, and there's so many fast ways you can do this. We know that this area, this area, this area, and this area is 95%. So I just need this area to help me out. Well, that is 2.5% if we remember. So there's so many ways that you can do this. So let's just add that up. 95 plus 2.5. So we get 97.5. So you could have a question where you're going to get, it may say in the question, the standard normal curve. And just remember, it's a distribution of z-scores. I believe in the problem set, you're going to see something like that, okay? All right, and this has been a 6-minute video, so I'm going to stop. That's all I needed to introduce with this. The follow-up to this is going to be more normal calculations, but it's going to be a little bit more complicated, okay? So I'm going to stop the recording.